What if I told you humans built a bridge higher than the clouds? This thing hangs 565 meters above the river, taller than the Eiffel Tower. You're literally looking at a bridge where planes fly underneath it every day. Driving across feels like floating through clouds with nothing below you at all. Before this bridge, crossing this gorge meant 5 brutal hours of mountain roads. Here's the crazy part. Those cables hold 10,000 tons of steel in mid-air.
I'm standing where engineers once said, nothing can be built here, ever.
Guizhou province in China has always been one of the most isolated places on Earth. Millions of people lived completely cut off. No highways, no fast routes, nothing. Wait until you hear this. Guizhou had no expressway at all until the year 2000. China's government made a bold decision: connect Guizhou no matter the cost at all. The problem was one monster gorge that stopped every highway plan for 13 years. Now you might be thinking, why not just build a regular bridge? Let me show you. Every traditional bridge design failed at the drawing board. The gorge was just too extreme. Engineers spent 2 years just studying this gorge before a single design was approved. The wind data they collected was absolutely terrifying. Gusts reached 140 kilometers per hour. In 2011, one genius engineer proposed the design that would finally make this work.
This blueprint was the key, a cable-stayed bridge using towers built on cliff ledges.
Construction officially began in November 2011, and the challenges started immediately. Some people will ask in the comments, how did workers even get down there to start? Every anchor point had to be drilled by hand into solid rock. No machines could fit. This is where it gets interesting. The site was so extreme that normal cranes couldn't work. Engineers designed a special cross-gorge cable system just to move equipment across the gap. Before anything could be built, a road had to be carved directly into the cliff itself. They used 200 controlled explosions to clear the cliff face, all perfectly calculated. After every blast, geologists inspected every millimeter of the remaining rock for weakness. Here's the crazy part. 2 separate teams built from both sides of the gorge simultaneously. Each foundation anchor was drilled 15 meters deep into solid bedrock. No exceptions made.
I can feel the vibration through my boots, the stad. This rock is being drilled into submission.
After 8 brutal months, both foundation pits were finally ready for concrete pours. The concrete pour for each tower foundation required 15,000 cubic meters poured continuously. They couldn't stop the pour midway. One crack in the foundation and everything fails. Inside that concrete is a steel skeleton so dense you could barely walk through it. Each tower had to grow from the cliff edge, not flat ground. Think about that challenge. Engineers used a self-climbing concrete form, rising 4 meters every single day consistently. Now you might be thinking, how do workers stay safe that high on a cliff edge? Every worker platform was fully enclosed. The wind up there could throw a man off easily.
Looking straight up this tower gives you instant vertigo, and it's not even finished yet.
Tower 1 reached 100 meters in just 62 days. They were breaking records as they built. Every meter upward required a laser check, 1 degree off vertical, and everything gets scrapped. While Tower 1 grew, the team on the other side was already 40 meters ahead of them. Winter hit them hard in 2012. Temperatures dropped below zero, but work never stopped. Inside each tower is a system of pre-stressed cables holding the concrete under compression. Every computer simulation showed the same result. This design could handle anything nature threw at it. This is where it gets interesting. The tower tops were now level with the gorge rim itself. The final tower cap had to be placed within 5 millimeters of the exact target position. Both towers completed in 18 months, 392 meters of concrete rising from cliff edges. Each tower top holds 56 cable anchor points, engineered to handle 4,000 tons of force. Wait until you hear this. After 18 months and 2 complete towers, the gorge was still empty. The cable installation phase was the most technically complex part of the entire project. Here's how it works. 56 cables per tower carry the deck weight directly to the foundations. Each cable contains 109 individual steel wires, all twisted together under precise tension. They used a helicopter to run the first thin wire across the 720-meter gap between towers. The pilot had to hover in 80 kilometers per hour crosswinds while workers attached cables. Insane skill needed.
I'm watching a helicopter thread a steel cable across a 720-meter gorge. Absolutely incredible.
Every new cable changes the tension on every existing cable. It's like tuning a giant guitar. Each cable is tensioned to within 1% of its target load. The precision is extraordinary. As cables tighten, they literally pull the deck sections upward into alignment. Watch this. After 28 cables each side, the bridge started looking like the harp of a sky giant. Here's the crazy part. The cables started singing in the wind, creating dangerous vibrations. They had to solve this fast. Uncontrolled vibration can fatigue a steel cable to failure.
The solution they found that night was elegant. Dampers installed inside each cable housing.
Viscous dampers, basically giant shock absorbers, were fitted to every single cable installed. Before and after comparison, same wind, same cables. The dampers completely solved the problem. 56 cables on Tower 1, all tensioned, all dampened, all perfectly aligned. Pure engineering art. Every cable was inspected centimeter by centimeter before the next phase could begin. 112 cables stretching across the Baypan River Gorge, one of engineering's most beautiful sights. When the final cable clicked into place, grown engineers were literally hugging each other and crying. 4 months to install 112 cables, each one a lifeline connecting man's ambition to solid rock. The deck had to be built from both towers outward at the same time, or it would tip over.
I just stepped onto the deck and I can see straight down 565 meters through a gap. Terrifying.
Each deck section was prefabricated off-site and flown in by the world's largest cranes. Every single bolt was torqued to a precise specification, then checked twice by inspectors. The welding was done 565 meters up, with nothing below them but a thin safety net. Now you might be thinking, what happens when those two arms finally meet in the middle? Every meter the deck extended, the stress calculations had to be recalculated from scratch. Inside the deck is a sealed steel box. Inspectors crawl through it, checking every weld. Some days the wind hit 120 kilometers per hour, but work stopped for nothing. Both deck arms grew simultaneously, and the closing gap became the countdown everyone watched. Here's the crazy part. When they measured, the two deck ends were 3 centimeters misaligned. By adjusting tension in just 12 specific cables, they moved the entire deck into alignment. After 18 hours of micro-adjustments, the two deck ends were aligned to within 2 millimeters. The closing piece weighed 120 tons and had to drop perfectly into a 120-ton shaped gap. When that closing piece landed, the two sides of the gorge became one for the first time ever. Every bolt team was synchronized by radio, 200 workers all moving at the exact same moment. Wait until you hear this. The workers started calling it the day the gorge disappeared forever.
I'm standing in the exact center where the two halves joined. This moment changed everything here.
1,341 meters of steel deck, completed in 10 months. The gorge was defeated. Before roads could be built, engineers laid a 20-centimeter reinforced concrete base first. Paving the bridge took 6 days, working 24 hours. They never stopped until it was done. Every safety system was installed simultaneously. Crash barriers, lights, lane markings, and signs. Those expansion joints allow the bridge to move 60 centimeters. Bridges breathe with temperature. In Guizhou's climate, the bridge steel expands and contracts by half a meter every year. This bridge has 600 embedded sensors. It reports its own health data in real time always.
Every sensor reading goes to this control room. Engineers monitor this bridge like a patient's heartbeat.
Some people will ask in the comments, how do you test a bridge this big? Like this. 80 trucks loaded to maximum weight drove onto the bridge at once. The deck deflected 45 millimeters. 45 millimeters of deflection. Exactly what the computer predicted. The model was perfect. They then made trucks drive at different speeds to test dynamic vibration response of the whole deck. The wind data matched predictions exactly. Years of research and testing all validated in one day. When they turned on the lights for the first time, villages in the valley below stopped and stared.
Standing on an illuminated bridge floating in darkness, this is the most surreal moment of my travels.
Before opening day, inspectors walked every centimeter of the bridge, checking everything by hand. The final inspection report was 4,000 pages long, every calculation checked and verified twice. After 5 years of construction, the Beipanjiang Bridge was officially declared ready to open. 3,500 workers built this bridge, and every single one got to walk across it before opening. The certification came through from Beijing: construction complete, safety verified, bridge approved. December 29, 2016, the day that changed Guizhou province forever, had finally arrived. The ribbon was cut at exactly 10 a.m., and the world's highest bridge officially opened. The first official convoy took 4 minutes to cross. The old route took 5 hours to complete. Elderly villagers cried. They had walked mountain paths their whole lives, and now this existed.
I'm in the first civilian car crossing, and I cannot believe what these humans have accomplished.
On the first day alone, over 3,000 vehicles crossed the world's highest bridge in operation. Within 24 hours, images of this bridge were seen by over 500 million people worldwide online. This bridge cut one business owner's delivery time by 97%. That's not progress, that's